right, a couple of equations here we're going to solve, and I'm going to solve them again in that kind of way where I leave all the numbers intact as they are, so that you can see where they end up in the end, leaving you the opportunity to kind of follow the pattern and figure out how you're going to solve a similar equation that doesn't have any numbers in it, where it's all variables. Okay, so a problem like this, there's actually a couple different ways we could approach this. We could do distributive property. In fact, we could go ahead and do that. So if I did distributive property, I'd end up with 3x minus 3 times 9 is 12. I would then add 3 times 9 to each side. 3x equals 12 plus 3 times 9. And then I would divide both sides by 3, giving us 12 plus 3 times 9 over 3. Another way I could solve this is I've got 3 x minus 9 or 12. Is I could just start by dividing by 3, because essentially I have two things being multiplied together here, and if I were to, like this, I would cancel the 3's out, and I'll just be left with the x minus 9. Let's go ahead and do that. So x minus 9 equals 12 over 3. And then I will add 9 to each side. X equals 12 over 3 plus 9. And if you were checking your calculator, this expression here and this expression here are the same. And if you look, if I wanted to put this back in, put these back together over the same denominator, I'd have to go, well, 9 times 3 over 3. 9 times 3 over 3. But if you can punch them in your calculator, you'll see you get the same thing. All right, this one over here. So we'll do distributive property method first. So let's see. That gives us negative 5 times 3x plus negative 5 times 5 equals 12. And I'll subtract over here. So negative 5 times 3x equals 12 minus negative 5 times 5. Notice I've got kind of this double negative going on over here. Now I'll divide by negative 5 times 3. So I'll get 12 minus negative 5 times 5 over negative 5 times 3. And we're done. And we could use the other method as well. And that one, negative 5, 3x plus 5 equals 12. So I'll divide by negative 5 right away. That's going to leave us with 3x plus 5. That's 12 over negative 5. And then I will subtract 5 from each side. 3x equals 12 over negative 5 minus 5. And then I'll divide by 3 on both sides. X equals 12 over negative 5 minus 5, and all of that over 3. Yeah. So you can see here, I have two different expressions, but they'll work out to the same value in the end, the same answer. There's two different ways of getting there. So this leaves you with a problem like A, let's see, A, bx plus c equals d, like this. A times bx plus c equals d. And how are you going to go about solving that? So think about the process we've used. Okay. One way is to distribute first. Okay. And then we can subtract or add or subtract to get rid of a constant term. Add or subtract to get rid of a constant term. And then divide by a coefficient. Divide by a coefficient. The other way is to start right away by dividing by this amount out here. And then adding or subtracting. Now this worked out pretty well because I don't have a coefficient of x. Over here I get an uglier expression because I have a coefficient of x, which means there's an extra division at the end. I have to first divide, then subtract, then divide again. But you can follow the same procedure with this expression here, and you'll end up with something much like what you've seen up above, except instead of numbers, they'll just be letters, variables.